Hello everyone, welcome to another tutorial video about algebra. We're going to be learning about factoring special cases of trinomials, specifically when we have perfect square trinomials. So we've done a little bit of this with multiplying special cases, but now we're going to be working and undoing those things. So here we got two examples. We're going to work on factoring these and then really point out what is going on that is making these special. So we've got 9x squared plus 24x plus 16. It's a trinomial. I'm just going to use my regular factoring method. So a is 9, b is 24, and c is 16. These are just my coefficients of each term. And to factor, I need two numbers that multiply to ac. So a times c, 9 times 16 is 144. And my two numbers also have to add up to b, which is 24. So let's think about what these two numbers can mean, or what they could be. Well, they're going to be two numbers that multiply. Well, 12 times 12 multiplies to 144. And 12 times 12, 12 plus 12 adds up to 24. So there we go. I've got my two numbers and they happen to be the same numbers. That's what makes this thing special. Let's rewrite this thing out now. So we've got 9x squared plus 12x plus 12x, my same two numbers, plus 16. Let's factor my two groups out. And in group 1, I've got a common factor of 3x. I'm going to factor that into 3x times 3x plus 4. And in my other group, I've got a factor of 4. A common factor of 4. So let's factor out that 4, and I'm left with 3x plus 4. Well, now this is interesting. So we've got common binomials of 3x plus 4 that I can factor out. But look at what I still have after I factor them. I still have 3x plus 4. So I've factored my trinomial into two binomials multiplied, but what I see is they're actually the same binomial. So I can rewrite this as 3x plus 4 squared, because I have two of them. And that's why we call this factoring perfect square trinomials, because it's a binomial squared that got me this original trinomial. And we're just undoing the perfect square part. And in general, so there's a certain pattern. Notice we just used our standard method of factoring any trinomial. But if you can recognize key patterns, notice if you have, so here's kind of your general pattern. If you have anything a plus b, a and b can be whatever terms. In this case, a is 3x and b is 4. If I square my binomial, it's always going to fit this pattern of a squared plus 2 times ab plus b squared. We see this pattern here in our own because if a is 3x and b is 4, well, look at what happened. So we have a squared, so 3x squared gives me 9, 3 squared is 9, x squared is x, and b squared at the end, so I had a 4 squared, that got me the 16. So anytime we have this special case, look for things squared, like 9 is 3 squared, 16 is 4 squared. But in the middle term, I have 2 times a times b. Well, what is 2 times 3 times 4 equal? It's going to equal 24. So if you can recognize, oh, there's something special going on, 9 and 16 are perfect square numbers. Are they related to the middle term? If you can recognize that, you might have a special case where you're factoring into a binomial squared, just like that. Let's take a look at another one. This other one over here involves subtraction. So let's go through. In this case, we've got a equals 49, b equals a negative 28, and c equals 4. I'm noticing something special might be going on because 49 is 7 squared and 4 is 2 squared. So maybe I'm dealing with perfect square numbers. But let's go ahead and use all my standard factoring methods. A times C, 49 times 4 is going to be 196. And B is negative 28. And I need two numbers that multiply to positive 196, but yet add to negative 28. And if you play around with this for a while, you see that it's negative 14 and negative 14. So kind of that other coincidental thing again, right? I get the same number added and multiplied to work it out. So let's continue on here, just like kind of this other term. So we've got 49y squared minus 14y. I'm going to change it to plus negative to help factor by grouping, plus negative 14y plus 4. All right, let's make my two groups. In this first group, what do we got in common? 49 and 14, I'm going to factor out a 7. And I'm going to factor out a y. So we've got 7y times 49 divided by 7 is 7. I'm left with a 7y plus negative 2. Over on this other group, 14y and 4. What do I have in common? I'm going to factor out a 2 from both of them. And because I'm noticing something going on with the negatives, the first term is negative, the second term is positive, but I want it to match this. I'm going to go ahead and factor out a negative 2. Negative 2 goes in the front, and now I have positive 7y plus negative 2. Well, it looks like we're ending up with the same sort of thing. I've got common binomials, 7y plus negative 2. I like that. But then I have another 7y plus negative 2 that I'm left with. So because I have the same thing multiplied, I can rewrite this as 7y minus 2 squared. And notice we have the same sort of pattern with subtraction. If you have a binomial, so a minus b, and we're squaring a binomial, well, the pattern in this case is you have a squared minus 2 times a times b, but then you still have plus b squared. So when we're factoring, we're looking for this pattern of squares. 49 was a squared, 4 is something squared, 7 times 2 gives me the negative 28. So it fits that pattern. If you can identify this pattern, sometimes you can make it easy to help you know you're dealing with something squared when you're trying to factor your trinomial into a binomial. But there you go. There's two examples of special cases where we're factoring a trinomial, but we see it's really the same binomial squared.